All good? Okay, fine. So let me share my screen and once let's recap what we have discussed so far in our previous session so that we will have an idea of what are we exactly discussing in this particular session, right? So 1 second, give me 1 second. Yes. So basically, in our previous sessions, we have started with this BCD adder, and we have discussed how BCD adder is going to work, like, and what is the circuit which we are going to design for a BCD adder or all. We have discussed in our previous session. Now, in this particular session, our main focus will be on implementing. First of all, let us try to understand what is a half subtractor and what is a full subtractor, and then we are going to discuss few questions like implementing a full adder but using half subtractor and implementing a full subtractor but using half subtractor. This kind of questions, if I want to discuss, first of all, we need to understand about how this adders and how your subtractors are going to look like, right? 1 second, let me connect this. Yes. So let us start the session. So as we have already discussed about adders, now we will discuss about half subtractors. Then we will start with the discussion of full adder using half subtractor and full subtractor using half subtractor, those kind of circuits. Right. Now coming to my half subtractor, as the name itself suggests, it is going to basically perform the subtraction, right? And your half subtractor is going to basically have only two inputs and it is going to have difference and borrow. So coming to my first circuit, which is nothing but my half subtractor, this is how it is going to look like. So I'm going to have a simple HS and I'm going to have two inputs A and B and I'm going to have outputs as difference and borrow. So this is my block diagram of my half subtractor, right? Now, if I want to draw the truth table of this particular half subtractor, this is how it is going to look like AB and difference and borrow. So I can have 0, 0, 0, 1, 1, 0, and 1, 1. So here the difference will be equal to 0 and borrow will be equal to 0. Here the difference will be equal to 1 and borrow will also be equal to 1. And here the difference will be equal to 1 and borrow will be equal to 0. And here the difference will be equal to 0 and borrow is equal to 0. So this is how my half subtractor truth table is going to look like. Can anyone tell me what is the equation for difference and what is the equation for borrow by looking into truth table? It's a simple question. What is the equation for difference and what is the equation for borrow? By taking the midterms, can anyone tell me what is the difference? What is the equation for difference and what is the equation for borrow? Waiting for your answers. Okay, simple. Difference have the midterms as 1 and 2, which is nothing but a bar b plus a complement, a b complement, which is nothing but a XOR with b. And borrow is going to have the equation as a complement b. That's it. Okay. So this is the equation for my difference, and this is the equation for my borrow. And if you carefully observe, the equation for your difference as well as the equation for your sum are both are equal. So you are going to have the same equation for your sum, and you are going to have the same equation for your difference. Okay. Now, this is about my half subtractor. Now, coming to my full subtractor. So, full subtractor is going to have three inputs, unlike our half subtractor. Full subtractor is going to have three inputs. Let me show you. So, coming to my full subtractor, I'm going to basically have three inputs with me A, B, and borrow input B in. And I'm going to have outputs as difference and borrow out. So these are the inputs and outputs of my full subtractor. And I'm going to have the truth table like this with three inputs A, B, B in, and two outputs difference and borrow out, right? So you have total 8 combinations for this: 0001, 010, 011, 100, 101, 110, and 111. So like this, we have total 8 number of combinations, and over here, my difference will be equal to 0, borrow out will be equal to 0, and difference is equal to 1, and borrow out is equal to 0, and difference is equal to 1, borrow out is equal to 1, and over here, difference is equal to 0, borrow out is equal to 1, and difference is equal to 1, borrow out is equal to 0, and difference is equal to 0, B out is equal to 0, and over here 0, 0, and 1. So this is my truth table of a full adder, right? Now, I mean truth table of a full subtract. Now, so what is the equation which I can have? What are the minterms for difference? Can anyone calculate the minterms for your difference and minterms for your borrow and come up with the equations? Waiting for your answers. So if you calculate minterms for your difference, you're going to have A XOR B XOR B in only, which is nothing but it is equal to sum. This is what you're going to get if you take minterms and solve it. This is what the equation you're going to get. And coming to your borrow out, B out, you're going to get the equation as B into B in, borrow in, plus A complement B plus A complement B. This is the equation for your B out you're going to get if you're going to solve. Okay. So this is about a full subtractor. As we have discussed about half adder and half full adder, we have also discussed about this full subtractor and half subtractor, right? Now, if I want to build a simple full subtractor but using half subtractor, this is the question we are going to have. So let's say suppose if my question is to build a full subtractor using half subtractor is the question. Sorry, full subtractor using half adder. This is a question. Take your time. You can take 2 minutes of time. And can anyone tell me how many total half adders I need to implement a full subtractor but using a half add? Is the question. Take your time and please let me know. So I need to implement a full subtractor but using a half add. What do you think? How many half adders do I need for this particular implementation? Is the question. You can take 2 minutes of time and think about it and let us discuss the solution. I need to implement a full subtractor but using a half adder. How many half adders do you think we are going to have? Anyone trying this question? Okay. Uh, am I audible? Please let me know in the chat box. Am I audible, right? Okay, fine. So let us discuss how to implement this particular full subtractor using half adder. Now, first of all, we will see how to implement a full subtractor but using a half subtractor. So for implementing this circuit, what is that we are going to have? We are going to have two half subtractors. This is half subtractor 2 and this is half subtractor 1, and I'm going to have A and I'm going to have B and I'm going to have borrow in, and this difference is given over here and B in is given over here, right? And here I'm going to get difference and borrow is being given from here. This is my full subtractor, but using half subtractor, right? Now, what is that I need to have? I need to have half adder in place of half subtract. Okay. So I need to first of all figure out how to implement a half subtractor, but using a half adder. I need to implement a half subtractor, but using a half adder, right? So half adder, we need to convert it into a half subtractor. Then we are going to get this answer, right? So coming to my half adder, I'm going to have input as A and input as B. And here, sum and difference will be same itself. Sum and difference are same. That is nothing but my A XOR with B. But in the case of your half subtractor, the difference will be A complement B. That is what the major difference is. Difference will be A complement B and carry out will be AB, right? So what we need to do, we need to just make sure that we are going to have complement to this particular A. Okay. So that is what I'm going to do. So what I'm going to do basically, I'm going to keep a NOT gate over here so that I'm going to get A complement B. So this C out will be converted to A complement B. But if you carefully observe, sum is also going to get disturbed, right? Because if you substitute over here, AX or B, where A is A bar. So it is A bar XOR with B. If you solve this, you are going to get A bar into B bar plus A into B, which is nothing but A XOR with B. But we need A XOR with B, right? Okay, if I'm going to expand this, this is what I'm going to get. I'm going to get A XOR with B. But what I need A XOR with B. So what I'm going to do, I'm going to keep one more NOT gate at my output so that I'm going to get A XOR B. This is how I'm going to convert a half adder into half subtractor. Okay. So this is how I'm going to convert a particular half adder into a half subtractor. Now, what I need to do, so I'm going to substitute this half subtractors with my half adder block diagram. So how I'm going to do, I'm going to take a half adder, which is half adder 1, and this is my half adder 2, and I'm going to basically connect a NOT gate at my A, and here I'm going to take B. And I'm just implementing this circuit. That's it. One more NOT gate and one more over here, and I have one more NOT gate connection over here, and B in will be connected to this, and here I'm going to get one more NOT gate over here. Here I'm going to get the difference. Okay, just I'm substituting this half subtractors with the whatever the modified diagram which I'm going to have, right? I'm substituting with this particular modified half adder circuit. That's it. Okay, so that it is going to look like this, and this output I'm going to give it to OR gate so that I'm going to get my borrow over here. Okay, fine. And if you carefully observe, this two NOT gates will cancel out each other and we are going to have a simple plain line. That's it. So this is how I'm going to implement a full subtractor using a half adder. This is how I'm going to implement. Is it clear for everyone? Any doubts or any queries over here? Please look into this particular diagram and let me know, is it clear? Any queries or any doubts over here? Okay, I hope things are clear, right? Yes. Now, let us try to implement a particular uh, full adder using half subtract. So if I want to implement a simple full adder using a half subtract, let's see how to implement this full adder using half subtract. Now, what is that I'm going to have? So full adder using half adder, we already know that we are going to have two half adders. Using that, we can build a full adder, right? But now we have a half subtractor. So we need to figure it out how to build a half subtractor using half adder. So we need to convert this half adder into a half subtractor. That is what we need to figure it out, right? So I'm going to have A and B connected to this inputs, and I'm going to have sum and CO at my outputs, right? And this is nothing but A XOR with B, and this is nothing but my A dot with B, right? Now, we already know that half subtractor output is AX or B, sum is AX or B, and the difference is A complement B. That means I can simply keep a NOT gate at A so that I'm going to get A complement B. But again, this will change. That's the reason I'm going to give NOT gate over here. If you have AX or B equation where A is equal to A complement, then if you are going to solve this A complement XOR with B, you are going to get A XOR with B. Just now we have seen. Okay. So that's the reason why what I'm going to do. I'm going to keep a NOT gate at my out. That's it. So this is how I can convert a half adder to a half subtractor by keeping NOT gate at the input and at the output. Now, how to implement this? I'm going to have a half subtractor implemented using a half adder. Okay. So this is how I'm going to have. This is my half subtractor, and this is my B, and this is one more half subtractor. This is one more NOT gate, one more NOT gate, and here I'm going to get my adder. Sorry, here this is my half subtractor. I'm implementing a half adder, right? So here I'm going to get my sum, and this is my scene, and this two I'm going to have the C out, right? And these two gates will be cancelled out so that it will be a simple plate. That's it. So this is how you're going to implement a full adder using half subtractor. So is it clear? Any doubts or any queries over here? Please look into this particular circuit and let me know. Yes. Now, let's say suppose if I want to design a adder cum subtractor circuit. Let's say it's a 4-bit adder cum subtractor circuit. If I want to design a 4-bit adder cum subtractor circuit. Okay. Now, for this, what I'm going to do, let's say I'm going to consider a 4-bit ripple carry adder. Okay. So 4-bit ripple carry adder is going to look like this. I'm going to have 4 full adders which are connected. This is full adder 1, and this is full adder 2, and this is full adder 3, and this is my full adder 4. Now, I'm going to connect A0, A1, A2, and A3. And here I'm going to get my S0, and here I'm going to get my S1, S2, and S3. And the carry from this stage is given to this stage, it is given to the next stages like this, right? Now, if I want to perform subtraction, what we have seen already that we can use the complement, right? A plus 1's complement of B is nothing but A minus B. This is what we have already seen, right? So instead of having a separate subtraction circuit in my design, what I can do is basically I can implement A plus 1's complement of B. Or else if I want to have the addition, I'm just going to perform A plus B. That's it. Okay. So that what I'm going to do is I'm going to take some kind of mode signal. So this mode signal, if it is equal to 0, I'm going to perform addition. And if this mode signal, if it is equal to 1, and I'm going to perform subtraction. This is what I'm going to do. Now, we already know the property of XOR gate. So if I take a simple XOR gate and if I give A or let's say B and one of the input is 0, then I'm going to get B over here. That means it is going to act as a buffer. But let's say if I'm going to take an XOR gate and I give B and one of the input is equal to 1, it is going to act as B complement. That is, it is going to act as a NOT gate. Okay. So this property of XOR gate, we are going to use it over here. So what we are going to do is simply we are going to take the input which is being connected to the XOR gate. So let me show you how I'm going to consider it. So I'm going to take a mode signal and it is connected all over here. And I'm going to take XOR gate. Now, one of the input of this XOR gate is connected to this mode signal, and another input is connected with this B. So it is B0, this is B1, and this is B2, and this is B3. Now, if my mode is equal to 0, then I'm going to add A3 plus B3, A2 plus B2, A1 plus B1, and A0 plus B0. But if my mode is equal to 1, then I'm adding A3 plus B3 complement, A2 plus B2 complement, A1 plus B1 complement, and A0 plus B0 complement. This is how I'm going to perform the subtraction. Okay. So this is how your 4-bit adder come subtractor circuit is going to look like, and it is being differentiated. And it is going to act as an adder if your mode is equal to 0, and it is going to act as a subtractor if your mode is equal to 1. Okay. So this was all about our adders, subtractors, BCD adders, ripple carry adders, and all, and implementing full adder using half subtractor and implementing full subtractor using half adder and all. These are all the designs which we have in the arithmetic designs. Now, next what are we going to discuss is we are going to discuss how to perform multiplication but using adders. That is what we are going to look into, and then we are going to discuss about code converters. Okay, and after that, we are going to start with multiplexer. As I've said you, in multiplexers, we are going to discuss a few problems over there so that we can get thorough knowledge on this multiplexers, right? Yes. So that's about this particular session. If you have any doubts on any other queries you wanted to discuss, you can stay and discuss with me, or else we can wrap up this session. Okay. Thank you.